Deploying and maintaining AI models is a crucial phase in the life cycle of an AI solution. It involves moving a trained machine learning model into a production environment where it can provide real-time predictions and ensuring the model continues to perform effectively over time. This process includes several steps, from initial deployment to ongoing monitoring and maintenance. Below, we will describe each stage in detail. AI model deployment. 1. Preparation for deployment model selection. Choose the best performing model based on evaluation metrics. Environment setup. Ensure the target production environment, cloud, on-premises, edge devices, is ready and compatible with the model's requirements. Code refactoring. Optimize and clean up the code to ensure it's production ready. This includes removing unnecessary dependencies and ensuring code quality and performance. Containerization and packaging. Containerization. Use container technologies like Docker to encapsulate the model along with its dependencies, ensuring consistency across different deployment environments. Packaging. Package the model using frameworks like TensorFlow Serving, ONNX, or custom APIs to facilitate deployment. 3. Infrastructure provisioning. Provisioning resources. Allocate the necessary computational resources, CPU, GPU, memory, required for model inference. Use platforms like Kubernetes for managing containerized applications. Cloud services. Leverage cloud services such as AWS SageMaker, Google AI Platform, or Azure ML for deploying models at scale. 4. Model serving API endpoints. Expose the model through RESTful or gRPC APIs to enable integration with other systems and applications. Batch processing. For batch predictions, set up workflows that process large datasets periodically. 5. Testing and validation. Smoke testing. Perform initial tests to ensure the model deployment is successful and the service is accessible. Validation. Validate the deployed model against a set of test cases to ensure it's producing the expected outcomes. AI model maintenance. 1. Monitoring performance. Monitoring. Continuously monitor model performance metrics such as accuracy, precision, recall, and latency. System monitoring. Keep track of system-level metrics like CPU, GPU usage, memory consumption, and response times. Error monitoring. Detect and log errors or exceptions that occur during model inference. 2. Logging prediction. Logging. Log inputs, predictions, and outputs to enable auditing and debugging. Event logging. Record significant events such as model updates, retraining events, and system downtimes. 3. Retraining and updating models. Data drift detection. Monitor for changes in data distribution that might indicate model performance degradation. Periodic retraining. Schedule regular retraining sessions using new data to keep the model updated. Version control. Maintain different versions of the model and track changes to ensure rollback capabilities if needed. 4. Scaling. Horizontal scaling. Add more instances of the model service to handle increased load. Vertical scaling. Upgrade hardware resources, more powerful CPUs, GPUs to improve performance. Load balancing. Distribute the inference requests evenly across multiple instances using load balancers. 5. Security authentication and authorization. Implement proper authentication and authorization mechanisms to control access to the model APIs. Data encryption. Ensure data in transit and at rest is encrypted to protect sensitive information. Vulnerability management. Regularly scan and patch the deployment environment to protect against security vulnerabilities. Tools and technologies. Deployment tools. Docker, containerization tool to encapsulate models. Kubernetes, orchestration tool for managing containerized applications. TensorFlow Serving, a serving system for deploying machine learning models. ONNX runtime, optimized runtime for Open Neural Network Exchange, ONNX models. Monitoring tools. Prometheus, monitoring system and time series database. Grafana, visualization tool for monitoring metrics. ELK Stack, Elasticsearch, Logstash, Kibana for logging and analyzing log data. Cloud platforms. AWS SageMaker provides tools for building, training, and deploying machine learning models. Google AI Platform, end-to-end platform for building, deploying, and managing machine learning models. Azure Machine Learning, cloud service for building and deploying machine learning models. Best practices. Automation. Automate as much of the deployment and maintenance process as possible using CI/CD pipelines. Continuous integration, continuous deployment, CI/CD. Implement CI/CD practices to streamline the deployment process and ensure that new model versions can be deployed reliably. Model versioning. Always version your models to ensure that you can roll back to a previous version if needed. Comprehensive testing. Implement comprehensive testing at all stages, including unit tests, integration tests, and system tests to ensure reliability and performance. Documentation. Maintain thorough documentation of the deployment and maintenance processes, including infrastructure setup, configuration details, and troubleshooting steps. Feedback loops. Implement feedback loops to gather user feedback and incorporate it into future model iterations. Conclusion. Deploying and maintaining AI models requires careful planning, robust infrastructure, and continuous monitoring to ensure optimal performance. By following best practices and leveraging the right tools, organizations can ensure that their AI models remain accurate, reliable, and secure in production environments.